Hello friends, how are you? Hope you are doing well. So today we are going to start discussion about scope 3 GHG emissions, greenhouse gas emissions, calculation examples. We'll see a lot of examples here and their solutions and questions and answers. So you will find it interesting, and this can be useful for all the ESG and sustainability professionals, learners and students. So first example, let us start with a category of upstream purchase goods and services. As you know, there are 15 different categories as per GHG protocol. Okay, so we'll see some examples. The first example is from upstream purchase goods and service. So the question is, a company purchased 50,000 units of an electronic component, okay, and the emission factor for producing 1 unit of the component is 3.5 kg carbon dioxide. Okay, so how many kilograms of CO2 are associated with the production of these 50,000 units? So you can see the correct answer is 175,000 kilogram of CO2. But how it came, how this answer came, so let us understand that actually. Okay, so we will see the solution of the question. We are talking about the category of upstream purchase goods and services. So what are these emissions? These emissions are associated with the production of goods and services of the company what are being purchased, and the emission factors, these are representing CO2 emissions generated during the production of each specific unit, actually specific unit of the product. So in the question it was given 50,000 units were purchased, okay, and the emission factor for each unit is 3.5 kg carbon dioxide. Okay, then how we did the calculation, you see emission calculation. So let us have this formula: total emissions is equal to quantity of units purchased multiplied with emission factors per unit. So the solution will be like 50,000 units multiplied with 3.5 kg CO2 per unit. So this will be the answer, 175,000 kg of CO2. Okay, that you can convert into tons also. Okay, so what are the sources of emission factor? Okay, this is also very important or interesting subject. Okay, and most of the students and learners are confused about it. So this emission factor of 3.5 kg CO2 per unit is typically sourced from industry specific, very important, life cycle analysis or LCA approach, life cycle assessments, or the database such as EcoInvent or greenhouse gas protocol guidelines. Also this contain emission factor based on different production processes and materials. So I hope you understand how this calculation taken place, how these emissions are being generated, and what is the source of emission. So this we apply here life cycle assessment approach, and we understand from where this emission factor is coming. Okay, now let us discuss the next example of the question. Now let us see the another example, upstream business travel. So what is the question? An employee travel by air for different business purposes. The one way distance is, let's say, 2000 kilometers. Okay, and the emission factor for this air travel is 0.115 kilogram CO2 per passenger kilometer. Okay, so what will be the total CO2 emissions for this round trip? Okay, so the correct answer is 460 kilogram CO2. But how this answer has come, let us see the solution of this. So in the solution part, if you see what is this category of emission, upstream business travel. So these emissions are being generated when any employee travel for work purpose, and this includes air travel, rail travel or car travel. And the emission factor for air travel depends upon the distance traveled and the mode of transportation. So let us see the data which is available now. 2000 kilometer he traveled, any employee traveling one way trip 2000 kilometer, and emission factor for this is 0.115 kg CO2 per passenger kilometer. Okay, so round trip distance will be multiply by 2000 into 2, so it will be 4000 kilometers. Okay, and the emission calculation will be, so emissions for round trip total, so whatever the distance is multiplied with emission factor, so 4000 kilometers into 0.115 kilogram CO2 divided by kilometers, so it will be like 460 kilogram CO2. Okay, so what is the source of emission factor? This is the main point here. So emission factor 0.115 kilogram CO2 per passenger kilometer has been taken from DEFRA, and that is from UK. So this is DEFRA, basically the Department for Environment, Food and Rural Affairs. This is, sorry, by mistake it has been written here, Department for Business, Energy and Industrial Studies. So you consider DEFRA is a Department for Environment, Food and Rural Affairs, okay, from UK. So guidelines for business, air travel or similar environmental agencies, like also we can consider EPA from US, Environmental Protection Agency. So I hope you understand how did this calculation happen. Okay, now let us discuss another example of the question. Okay, so now next example is upstream employee commuting. Okay, a company has 100 employees, okay, 100 employees who commute to work using private cars. So each employee drives, let's say, 20 kilometers per day, and that is also one way. Okay, so the emission factor for gasoline car is, let's say, 2.3 kilogram CO2 per liter, and the average fuel consumption is 0.08 liters per kilometer. Now, how much CO2 is emitted from employee commuting in one day? So correct answer is 736 kilogram CO2. But how this answer came, let us see the solution part of this question. Okay, if you see the solution here, when we talk about the upstream employee commuting, this is including emissions from daily commute of employees, and the emission factor depends upon basically the fuel type and also the vehicle's efficiency, or which vehicle is being used. So whatever the given data is, like number of total employees traveling 100, what is the distance traveled one way, that is 20 kilometers. Please keep in mind this is one way distance. Okay, and then emission factor for the gasoline 2.3 kg CO2 per liter, and what is the fuel consumption or vehicle efficiency, that is 0.08 liters per kilometer. So what will be the calculation? So first we need to calculate fuel consumption, that is per employee per day. So we have to multiply the kilometers in one way multiplied with fuel consumption, that is the efficiency. So the answer will be 1.6 liter per day actually, that is the fuel consumption per employee. Now next what we have to calculate, the total fuel consumption for all the employees. So multiply this with 100 actually, because the total number of employees are 100. Now calculate the total CO2 emissions from all employees commuting. So what we have to do, we have to multiply this with the emission factor. Okay, that is 2.3 kilogram CO2 per liter. So total will be like 368 kg CO2 per day. Okay, now this is one way. Okay, one way commuting actually. Now if we say round trip travel, then we multiplied this with 2 and the answer will become 736 kilogram CO2 per day for round trip. Okay, and this emission factor has been sourced from, okay, we can refer these websites, EPA, Environmental Protection Agency from US, and DEFRA from UK. Okay, so this is about gasoline uses in passenger vehicles. I hope you like the example. Now let us discuss another question. and its example. Now we will discuss the next example, that is downstream uses of sold products. Okay, so the question is, there is a company who is manufacturing 500 units of product and that uses or consume 1 kilowatt of electricity per day during its using phase. Okay, the emission factor for electricity is 0.4 kg CO2 per kilowatt hours. Okay, so how much CO2 is emitted per year from the use of these 500 units? So the answer is 73,000 kilogram CO2. But how this answer came? Let us see the solution part now. In the solution, if you see here, particularly for this downstream use of sold product, these emissions are occurring from the uses of sold product, especially when these products consuming energy during their life cycle, such as electricity. Okay, what is the given data here? 500 units were sold. For each unit, the electricity uses is 1 kilowatt hour per day, and emission factor for this is 0.4 kg CO2 per kilowatt hour. Now we consider it for 365 days in a year. Okay, so let us start the calculation. First we have to calculate the electricity consumption for all the units per day. So 500 units multiplied with 1 kilowatt hour per unit, that is the electricity consumption for one unit. Okay, so the answer will become 500 kilowatt hours per day electricity consumption for all these 500 units. Now calculate the total CO2 emissions per day. That will be like multiply this with the emission factor, and the answer will become 200 kg CO2 per day. Now this is for one day result. Okay, we have to talk about the whole year. Then what will become? You multiply this with 365 days, so answer will become 73,000 kilogram CO2. Okay, so this emission source, again as we discussed earlier, emission factor 0.4 kg CO2 per kilowatt is commonly taken from regional electricity grids or energy providers. Now in this case, for example, like DEFRA, EPA provide emission factors based on the energy mix of grid. Okay, I hope you like the example. Let us discuss another question. The next example is about downstream waste disposal. A company which is producing 1000 tons of waste annually, and the emission factor for this waste disposed in landfill. So please keep in mind, we are talking about landfill waste disposal, and the emission factor is 0.1 kg CO2 per kg of the waste. So what will be the total CO2 emissions from the waste disposal? So we have to find out for 1000 tons of waste annually. This is being produced by this company, the waste produced by this company. So the answer is 100,000 kilogram CO2, 100,000 kilogram CO2. But how this answer came? Let us see the solution part now. The solution says that these emissions are occurring when the company waste is disposed of in a landfill, and emission factor considers the emission from basically decomposing the waste in the landfill. So this is downstream waste disposal, and majorly the emissions are coming from decomposition of the waste. So what is the total amount of the waste produced? This is the given data, 1000 tons annually, which we convert into kilograms. Okay, and then emission factor for landfill waste disposal is 0.1 kg CO2 per kilogram of the waste. So what will be the total CO2 emissions? You see, multiply this with the emission factor and you will get the answer now, 100,000 kilogram CO2. So emission factor, basically this what we have taken or referenced is typically taken from DEFRA's waste emission factors or EPA's greenhouse gas inventory. Okay, so this is the example about downstream waste disposal, but particularly for landfill, so where the decomposition of the waste is taking place. Let us see now the another question, another example. Another example is upstream capital goods. So there is a company invest in new machineries that requires 10,000 kg of steel for manufacturing, and the emission factor for producing this steel is 1.8 kilogram CO2 per kg of steel. So 1.8 kilogram CO2 emissions per kg steel. Now, what is the total CO2 emissions from the production of steel used in this machinery? So the answer is 18,000 kilogram. But how this answer came? Let us see the solution part. We see upstream capital goods like long-term assets which are used in productions, and the emission, these are stemming from the manufacturing of the equipment, machinery and other long-term assets. Okay, so this, to understand these emissions, basically we need to follow the life cycle analysis again. Okay, and we have to find out what are the life cycle inventories, and the given data in the question is amount of the steel used is 10,000 kg. Okay, and the emission factor is 1.8 kilogram CO2 per kg of steel. So CO2 emissions will be like amount of steel multiplied with emission factor. So these are multiplied, and this is the answer, 18,000 kg CO2. This emission factor is sourced from database like EcoInvent or industry specific life cycle inventories, and that is tracking emissions from manufacturing process such as steel production. So this is about upstream capital goods category. Okay, now let us see another example. We'll talk about one more case related to upstream transportation and distribution. The question is, a company is shipping 1500 tons of raw material from a supplier who is located 500 kilometers away, and the emission factor for transporting goods by truck, please keep in mind transportation with truck, and that is 0.15 kg CO2 per ton kilometer. Now, what is the total amount of CO2 emissions from the transportation of these raw materials? So the answer is 112,500 kg CO2. But how this answer came? Let us see the solution now. In the solution, if you see the upstream transportation and distribution, these emissions in the category basically including transportation of goods from the supplier to the company, and the emission depends upon what is the distance traveled, weight of the goods, and type of the transportation we are utilizing. Okay, what is the given data here? The amount of raw material, that is 1500 tons. Okay, and the distance is 500 kilometers. The emission factor for a truck transportation is this, 0.15 kg CO2 per ton kilometer. So what we have to do to find out the total CO2 emissions, we have to multiply the weight of the goods, distance and emission factor. So the data is given here respectively, and the answer comes after the multiplication. Okay, another important thing is from where this emission factor is coming. So take an example of DEFRA's GHG reporting guidelines, okay, or the emission conversion factors, and the transportation emission database, depending upon the reason and the type of the transportation we are utilizing. I hope you like the question. Now let us see another example. Another example is about upstream waste generated in the operation. So a company is generating 2000 tons of waste annually during the manufacturing process. The emission factor for waste generation, which is related to incineration, okay, previously we have discussed about the landfill. So incineration, the emission factor is 0.5 kg CO2 per kg of the waste. This is an example here. And what is the total CO2 emission for this waste? So the answer is this, 10,000 kg CO2. Okay, but how this answer is coming? Let us see the solution. In this category, particularly upstream waste generated in the operation, this include the emission which are associated with the waste generated by the company in its operations, whether it is disposed in landfill, incinerated or recycled. Okay, now the given data here, amount of waste generated is 2000 tons, and which we convert into the kgs. emission factor is given here. So to find out the total emission, you multiply the waste into amount of the waste into emission factor. So the answer will be coming like this, because this is the total waste quantity and emission factor. Again, to source the emission factor, we can go to the waste treatment guidelines provided by DEFRA or other regional waste management organization, typically based on the waste disposal methodology. This is very much important. So we have to understand what is the disposal methodology, like either landfill, okay, or incineration or recycling. Okay, I hope you like the question. Now let us discuss another example. Another example is related to downstream transportation and distribution. Downstream transportation and distribution, there is a company selling 10,000 units of a product, and this product is being shipped to customers using a truck, okay, and that is emitting 0.2 kg CO2 per ton kilometer. If the truck travels a distance of, let's say, 200 kilometers, and the total weight of the units, 10,000 units we said, is 50 tons. So what will be the total CO2 emissions for this downstream transportation? The answer is 2000 kg CO2. But how this answer comes, let us see the solution of this. In the solution side, first we define the particular category of the emission. This is including emissions which are from the distribution of the products after they are sold, including shipping, warehousing and delivery. And the weight of the product is, let's say, 50 ton, distance traveled 200 kilometers, and the emission factor is 0.2 kg CO2 per ton kilometer. Now multiply all these things, weight of goods, distance, emission factor, and these are given respectively, like 50 tons multiplied with 200 kilometers and into 0.2. So the answer will become this. So again, to source this emission factor of 0.2 kg CO2 per ton kilometer, which is can be taken from DEFRA emission factor from EPA for transportation, also taking into account, very importantly, the energy efficiency of the vehicle and also what type of vehicle it is actually. So energy efficiency and type of vehicle used, these are the two major factors to decide this total amount of emissions. I hope you like the question. Then let us discuss another example. So another example is related to the downstream end of life treatment of the sold products. So what is happening here? A company sells 5,000 products each year. Now end of life treatment of each product involves 2 kg of material being recycled, and the emission factor is for recycling 0.3 kg CO2 per kg of material. Now what will be the total CO2 emission from the recycling of product at the end of their life? What we are doing, recycling of sold products, okay, that is basically end of life treatment. So answer is 3000, but how we will see the solution part. Now in this downstream end of life treatment sold product, basically the emissions are generating from the treatment of products after they have been sold. So in this include recycling, incineration and landfill, but here the case of recycling. So number of products sold 5,000 units, this is the given data. What are the material recycled per unit? 2 kg, and emission factor is this 0.3 kg CO2 per kg of material. Now the total emission, we will see, multiply this total number of units and material recycled per unit, so it will be 10,000 kg. Okay, now what we have to multiply this with emission factor, so we will get the answer of total CO2 emissions. Again, we can follow the DEFRA for or either National Waste Management Organizational Guidelines for recycling processes to find out what will be the respective emission factor. I hope you like the question. Let us see another example now. Another example is related to upstream business travel, that is air travel. So the question is, a company has 20 employees who each take a one-way flight of 1200 kilometers for business purpose. Now the emission factor is this. What will be the total CO2 emissions? So the answer is 2760, but how this comes, let us see the solution part. In the solution part, business travel, which is air travel for upstream business travel category. In this, emission include the CO2 emitted because of the flights, train rides and car travel for business purpose. Actually, what is the given data? Total number of employees 20, one-way flight distance is 1200 kilometers, and emission factor is 0.115 kg CO2 per passenger kilometer. Now what we have to do? We have to find out CO2 emissions per employee, distance traveled multiplied with the emission factor, and this is the answer for one person. Now what about the 20 employees? Multiply this with the number of employee and you will get the answer related. Again, similarly, we can source the emission factor either from DEFRA or EPA website or the guidelines for air travel actually. Okay, let us see another question now. We have one more case of downstream transportation of the sold product. A company that is shipping 15,000 units of the product, each is weighing 5 kg. The distance traveled is 800 kilometers. Okay, so emission factor is given. Now what will be the total CO2 emission for transporting these products? So the answer is 12,000 kg, but how this answer is coming, let us find it out. If we see the solution, that's downstream transportation covers the emissions from the transportation of product from the company to the customers. Total units 15,000. Weight per unit is 5 kg. Distance traveled 800 kilometers. And emission factor for truck transportation basically, as it is talking about the truck, 0.1 kg CO2 per ton kilometer. Now what will happen? First calculate the total weight of the products. Total weight is 15,000 unit multiplied with 5 kg each unit. So that will be total, and convert it into the tons, 75 tons. Now what will be the total CO2 emissions? 75 multiplied with kilometers and the emission factor. So the answer is 6,000 kgs. Okay, so answer is 6,000 kg CO2. So let us go back to the question again. Here it will be correct answer is 12,000, which we were discussing earlier. No, this is the correct answer. Okay, you find it out? Yes. Now let us go to another question. Upstream employee commuting. A company has 50 employees. Each employee drive an average of 30 kilometers per day with a gasoline powered car, and the emission factor is this. Average fuel consumption is this 0.08. Okay, so what is the total CO2 emission for employee commuting in 1 year, assuming 250 work days in a year? So let us find it answer whether it is correct or not in the solution. Okay, so let us see employee commuting, that is the category which include emission from the commute of employees to and from the work, and the emission depends on what type of the fuel we are utilizing and the kilometers distance travel. Now there is a given data available: total number of employees, distance per day, fuel consumption, emission factor is given. Okay, now total work day is also assumed. Yeah, so first we find out fuel consumption per day. So 30 kilometers, that is one way, and multiplied with fuel consumption, that is 2.4 liter per day is being used. So total fuel consumption for all employees, this is multiply with total number of employees, this, and then calculate CO2 emissions per day. Okay, so multiply this with with emission factor, and this will be the answer: 276 kg CO2 per day. But for the whole year, as we have to multiply this with 250 days. Okay, now what will be the answer? 69,000 kg CO2. So the correct answer is A. Okay, so not this. Okay, so be careful. Yeah, so that's why we have to go through the detailed solution and find out what is the correct answer. Okay, let us see another question. Upstream purchase electricity for manufacturing. In this category particularly, let's see the question. There is a manufacturing facility which is consuming 100,000 kilowatt of electricity annually, kilowatt hour annually, and the emission factor is 0.4 kg CO2 per kilowatt. So what will be the total CO2 emission? Let's find out whether this is the correct answer or not. Let us see the solution. So the upstream purchase electricity emissions are basically the emissions which are generating from the electricity the company is purchasing to run its operations such as manufacturing facilities and office buildings. The given data was, this is the quantity consumed of electricity, 100,000 kilowatt hours in year, and this is the emission factor. Multiply them both and that will give you the answer of emission for upstream purchase electricity. And again we can refer DEFRA and EPA website for this emission factor, and again reflecting the carbon intensity for the electricity grid actually. Again we can see some example of downstream end of life products. There are 20,000 unit of the product. Each unit is generating this amount of waste, and end of its life, which is again incineration we are doing. Incineration of waste is giving this much 0.9 kg CO2 per kg of the waste. And let's calculate the total emissions. Let's find out whether the answer is correct or not. So end of life treatment, as I told you before, that when we talk about this category emissions, we are talking about disposal or recycling of the products at the end of their life cycle, and the product is being incinerated, so CO2 emissions from the process are counted here actually. Total units manufactured 20,000 units, waste per unit 1.5 kg, and the emission factor for incineration is 0.9 kg CO2 per kg of the waste. Total waste we need to find out first. Total units multiplied with the waste generated 1.5 kg per unit. So this will be the total waste. This is being sent for incineration, so multiply this with emission factor and you will get the answer for the question. So 27,000 is the correct answer, and this waste is being incinerated typically, so the emission factor we can refer again DEFRA and EPA website waste management emission data. I hope you like the question and answers and their solutions. One more important thing which I wanted to share with you about reference emission factor. So you can refer DEFRA's website, EPA and greenhouse gas protocol website. So these three emission factor reference sources, very important. Every ESG sustainability student learner must know about these three websites. This is from DEFRA. Again I will repeat, Department of Environment, Food and Rural Affairs. Then EPA, Environment Protection Agency from US. We can go through with this emission factors hub, and the greenhouse gas protocol. Excel sheets are available where you can see stationary combustion, mobile combustion and other emission factors also. So these three websites will be very useful and important for all the ESG learners and students. I hope you liked the question and answer. These are certain sample examples only. If you want to learn more about this calculation of scope 1, 2, 3 and emission inventory of GHG, do write in the comment, and can write to my LinkedIn profile also, or to the ESGS Academy LinkedIn profile also. Thank you very much, friends.